Few weeks ago, I tested GLM 5.2 for revamping my portfolio, and I really liked the results. At that time, I was using it via the open code subscription. Since then, I wanted to run GLM 5.2 locally on my Mac, but I knew it wasn't possible. So just yesterday, I came across this repo. So in this video, I will be doing the setup live in front of you, and then I will be testing it, whether it's actually useful or not. So without any further ado, let's jump straight into it. This is that open source repo called Colibri that allows you to run GLM 5.2, the 744B mixture of experts variant on a 25 GB consumer machine. So I just want to test this exact setup. So we will be doing it live. As you can see the stats, this repo is sitting at 17,000 stars and around 1.7K folks. And if we see the README file, it clearly mentions that it is a lightweight, quality preserving MOE runtime that treats VRAM, RAM, and storage as one managed memory hierarchy. And the whole vision is frontier models should not be sealed inside data centers. So that's the reason this repo exists. And we will be actually testing it live to see if we're able to run it. And if we are able to run it, is it actually useful? So to give you some context, I would be running this on my Mac, which is 24 GB RAM, and it is a M4 Pro variant. So that's about the hardware that I would be testing this on. In the README, you can check how it works and all the other details. If you're someone who wants to follow this along with me, I will put in the repo link in the YouTube description. Do check it out. As you can see on the terminal, I've cloned the Colibri repository. Now let's jump straight into the setup. There are two ways for the installation as well. Like you can go to the GitHub releases page and download the archive directly from there, depending on the platform that you are on. But in my case, I would be building it from the source since I am on Mac and I'm using the Metal Edition. So we will follow the steps specific to Mac OS. So this was the first step, and it says command line tools are already installed. As you can see, now we are downloading libopenmp, which is for multi-threading, Git, and Python. These are just dependencies. So the step two is to get the code and build the engine. And if everything is working fine, then you will see 32 by 32 passing. Since I'm on Mac and I want to leverage it, the steps that we will be performing here will be slightly different. I'll walk you guys through the steps one by one. So we will go inside the C folder, and in here we are going to run make colibri metal equal to 1. And next up, we will run make metal test. So it says the metal backend tests are okay. The third step is to get the model. And in here, there are two ways to do it. The easiest one is to download a ready-made int4 container. And the other one is to convert it yourself from a FP8 source. And for this video, I will be sticking with the easiest option, which is to download a pre-converted GLM 5.2 model from Hugging Face. And the point to note here is the size of this model is 372 GB. So before downloading, you need to ensure that you have enough space on your machine. If you are on Mac, you can check that by typing the command df space -h, and you can see the available space is 384 GBs, which is greater than what we need. So we should be good to download the model. Here we are on the Hugging Face, and this is the model that we need to use. It is under MIT license, and this is having close to 100 likes. And if you see, it clearly mentions that the int4 version was having low acceptance rate and was basically useless. So that's why they're recommending to use this one, which is the int8. And it says it only works with the Colibri engine. And here they have given the usage. We are done with the first step, which is to get the engine up and running. And we will be following this step, which is to download this repo to a fast local disk. We are back to terminal and I've copied that command. Let's paste it here. Okay, so it says I don't have the Hugging Face CLI. So first we are going to get the Hugging Face CLI. And how we can get the Hugging Face CLI is, here we can see I'm on the official documentation under CLI, and it says the recommended way on Mac is to use this command. So I'll just copy it. So once we have installed it, we can check if the CLI is correctly set up. So this is the curl command to download the Hugging Face CLI. And the CLI has been installed successfully. To check, we will run hf-help. And here you can see the help command gave us the different options and commands. Now let's run that hf command again, which is to download the model. And in here, we are getting some errors. Let's see what's happening. The local directory path that I have given, which is nvme, it says that this path doesn't exist. So it's failing at this file not found error. nvme is a read-only file system. I cannot write anything in there, which is interesting because the usage tells us to use this. So I discovered that this nvme folder under root is Linux specific and is something which we cannot do on Mac. So for us to give us a fast disk, it basically means space on the disk where you can write. So we can change this local dir path to anything. So I'll copy this command. And for the local dir, we will say under home folder models glm 5.2. Let's go. So now you can see the download has started and it is at 1%. So we know this is around 380 GBs. It's going to take a long time. I'll let it download and I will be back once the download is done. One pro tip for you when you're downloading the model from Hugging Face is that try to give it the Hugging Face token so that the download can be a lot faster. When I started the download for the first time, I left it overnight, and when I came back, it failed in between. But what's the best thing is the download will continue from where it failed, so the download can resume itself. And I just gave it my Hugging Face token, so it could be a lot faster. So that's one tip that I wanted to share with you. So here you can see I'm running the JLM 5.2 locally through Colibri, and these are some of the parameters that I have given in, like Koli metal, which is to take leverage of my Apple metal, and then the cache route direct as true. And I'm also using this RAM setting where I'm forcefully asking the model to occupy 40 GBs of my RAM so that it can be quicker. And here I've asked it to create my UGC portfolio. I've given in just my YouTube channel, and I think this will take a long time, but this is the whole idea. I'm asking it to create my UGC portfolio, and once it is done, I'll show you the result. I feel the whole experience of running GLM 5.2 via Colibri, even though my Mac supports 48 GB, it's not very smooth. I know Colibri says that it can run on a 25 GB consumer hardware, but that's not true. I mean, it can run, but it won't be usable at all. I'll show you some instances of how the response was. So I tried to run it using different parameters and different settings, and it's the same task that I wanted it to do, which is to create my UGC portfolio. It says it cannot directly click or view external links. So it cannot access my YouTube. And it says I can help you build the site. So first, it's asking me to choose the platform. So it's suggesting me different options, which are no code, low code, and code it yourself. And this took like a long time just to get through the step one. So I stopped in between. Then I tried again, and this time I said, build a website for me, right? And here it's trying to bring up a HTML page. It's giving me this code. But again, this was super slow. So even though I'm able to run it on my Mac, I'm able to run this Colibri, which allows you to run GLM 5.2 on consumer hardware, but I wouldn't count it as usable because it takes a lot of load on the machine. Plus, I have to wait hours and hours, and sometimes when it's generating the response, it will just stop in between. So it's not reliable, even though the Colibri says it's runnable on a 25 GB hardware, but that's not clearly the case. I have 48 GBs of RAM. I'm struggling with it. So I very much wanted to give this out. I know this is kind of failed experiment for me, but I just wanted to let you guys know the steps. And if you're somebody who's having more RAM or who's having the hardware to be able to run this, then you might find this useful. Do give it a shot and let me know what you think. There's just one more thing that I wanted to talk about, that all these videos that I create, it's not just to show the success and the happy scenarios in there, I also want you to know about the failures, how I debug issues. And in this case, clearly, even after trying multiple iterations, even after trying multiple parameters, it is clearly not working. So unfortunately, I'm not able to run it, but it was a good try. I would say still the repo is useful, and it would have been fun if I would have been able to produce some output from it. But yeah, that's what I have for this video. And if you want more such videos, let me know in the comments below. And if you're new to the channel, make sure to hit that subscribe button. It will motivate me a lot to keep on creating content like this. I'll see you in the next one. Bye bye.